Good morning, everyone. My name is Engineer S.D. Singh, and today we are going to record the lecture on three-phase transformers. So, in this particular video, you will be having introduction to the general working of three-phase transformers. What are the basic concepts? How it is being constructed? And what are the advantages and disadvantages of three-phase transformers? Okay, now let us start. Now, as you all know, there are two types of transformers available in our engineering classes, in our engineering domain. The first one is single phase transformers. Now, in the single phase transformers, there are basically two windings, the primary one and the secondary one. The input voltage is applied to the primary side and output voltage is obtained at the secondary side. This all happens due to the two concepts. The first one is mutual induction and the second one is introduction of Faraday's law, which is having the formula E is directly proportional to d phi by dt. E means the induced voltage and d phi by dt means the rate of change of flux. So E is directly proportional to d phi by dt. And the second concept is mutual induction. Now, all the working principle of the single phase transformer is analogous to the three phase transformer. The only difference is that it is having three windings. The only difference is that it is having three windings. Now, the three windings means for each winding there is a secondary winding which is on the other side of the transformer. For example, if there are three windings, let us say this is the first one, A, let us say there are three windings, and this is the primary side, A, A dash, B, B dash, C, C dash. These are connected at a single point. This makes the neutral point. Let us say this is the primary side, and on the secondary side, corresponding to this winding, there will be a secondary winding. Corresponding to this particular winding, there will be a secondary winding, and corresponding to this primary winding, there will also be a secondary winding. Although there are different types of connections for this secondary winding, but still you can remember the operation is same. Only difference is there are three phases or three supplies in the primary side and three supplies on the secondary side. Now let us start formally with this PPT. So the question might come into your mind, from where does the three-phase supply comes? So this happens on the generation side. So whenever three-phase generators are used, three-phase induction or three-phase synchronous generators are used, the supply is obtained in the form of three-phase supply, which is displaced from each other by an angle of, or you can say the angular difference between these three supplies would be 120 degree. These are equally apart. Now why this happens? There is a detailed study on that. There will be a detailed concept on that, and I will try in the future lectures that I will give you with the conceptual details of how three-phase supply is generated. Till now, just remember, let us say there is a generator which is having three windings in the rotor, sorry, in the rotor there are, let us say there are three windings, the first one, second one and third one. Let us say there is a permanent magnet around these, north and south magnet. Now if these three windings are rotated, they will cut the flux, of the permanent magnet. Now what will happen whenever a winding is observed, a differential flux or the flux which is changing with respect to that particular winding. Now as the rotor rotates, the winding will observe that the flux is being changed with respect to time. It will generate a supply. So as these three windings are 120 degree mechanically apart, these are placed 120-degree mechanically apart. They will observe the production of induced EMF in all three windings, which will be 120-degree apart electrically. So the graph obtained of the three windings of the induced EMF in these three windings would be like this. So let us say in the A winding, it is represented by the color red. In the B winding, the same EMF will be produced, but it will be displaced by an angle 120 degree. It will be displaced by an angle of 120 degree. So if this is the maximum of two A and B, they will be displaced with each other by the angle 120 degree. And similarly is the case for the winding C. So there will be a 120-degree displacement between each of the electrical signals induced. Now, the mathematical expression for the instantaneous voltages obtained in these three windings would be this. So in the first winding, let us say A1 and A2 is our reference winding. Let us say this is A1 and this is A2 end of this winding. This is B1 and this is B2. This is C1 and C2 end of this winding. So the voltage between A1 and A2 would be Vm sin omega t. The voltage between B1 B2, which is 120-degree apart from the first one, it will be Vm sin omega t minus 120-degree. Similarly, the voltage between C and C2 will be Vm sin omega t minus 240-degree. So all these three voltages will be 120-degree electrically apart. Okay, so in this way we obtain 120-degree apart, electrically apart voltages. Let us come to the next slide. So these are the connections. These are the windings that we have discussed, that these are present in the rotor or armature of the generator depending upon the type of generator we are using. So if these are the three windings, A1, A2 for a single line current, B1, B2 for second line current, C1 and C2 for third line current. Let us name them as R, Y and B. Now if I connect, or if we connect these ends together, A2, B2 and C2, it will result in a star connection. It will result in a star connection because its figure resembles like a star. So in the diagrams in your books or in any professional material that you will read, it will be like this. It can be, the star connection can be represented as this. So similarly is the case for delta connections. So there are basically certain differences between the voltages obtained that we will discuss in the next slide between these two type of connections, star and delta. So if these are the three windings, if we connect this part, if we connect let us say A2 with B1, if we connect these windings in this way, it will result in a delta like connection. So A1 is connected to C2, A1 is connected to C2, A2 is connected to B1, A2 is connected to B1, and C1 is connected to B2, C1 is connected to B2. So if we connect these three windings of the generator in this way, we will obtain a delta connection. And on the professional materials, you will see or you will observe diagrams like this. So these are the diagrams for star and delta connection. So these are the basic connections that we can make on the supplies that we obtain from the three-phase systems. So why we are discussing that? Because the transformer, the three-phase transformer will receive a supply from the three-phase generator, and that can be a star type or it can be a delta type. Okay, so this is the example. Let us say we have received this three-phase supply, which is line 1, line 2 and line 3. We can represent this as R, Y and P. This is also a line that is not very visible. I can redraw it for you. And this is the neutral wire that we have obtained from the generator itself. So this is a typical example where resistance of each coil is taken as 25 ohms, but still I can generalize it in a way that the voltage, this voltage, let us say the voltage of a particular coil in a star connection, this voltage you will obtain will be 230 or 220 volt. And if we obtain voltage from this point A and C, let us say, we will obtain a voltage of around 440 volt. And the coil voltage or the individual line voltage, let us say this is A dash. So this coil voltage means the voltage between A and A dash, it will be is equal to the line voltage divided by root of 3. That is 230 volt is the result of 440 by root of 3. So there are particular derivations for this particular concept. I am only discussing here for your information only. Okay, but the coil current, this current will resemble the this current and this current. So the coil current will be same as the line current. That means the current flowing in the portion AA dash will be is equal to the current flowing outward from the wire A. But on the other hand, in the delta connection, the voltage across the coil will be same as voltage of the line because these are connected with each other. But the current in the coil will be is equal to root 3 times of current in the uh, root 3. It will be the division of line current by root 3. So these are the some basic concepts. Let us now move further.